Okay, so this workshop is going to be on QuickSort, and we'll implement that from scratch. First, I would like to explain to you how it works. All right, so in the lectures I did explain the basic idea, but I did not give you an algorithm, right? So this is what we'll do now. So can I draw a rectangle? Maybe there is a way, but I don't know. Alright, so let's say that we have an array and we would like to sort it. So the way this thing works is we take a pivot point, let's say a 7, and then we place all elements which are less than 7 on the left hand side and all elements which are bigger than 7 on the right hand side. Okay, then we take these two subarrays and we do the same thing. Okay, so in here we take a pivot point. Let's say that in this case it's something like 3. We place all elements which are less than 3 on the left side, and then all elements which are bigger on the right side. So if you do this enough times, in this case we need to do it one more step. We'll just get 2 elements, they will be sorted, and we will be pretty much done. So yeah, this kind of technique is called divide and conquer. I think that's how you spell it. And it's used both for QuickSort and merge sort, which is going to be on our next workshop. Alright, so that's pretty much how it works, but then, you know, here you may have had the impression that you would have to create, you know, a lot of arrays and so on, and it can be kind of tricky. How would you put all of that into a single array and do all of the calculations there? So now let's discuss. It's going to be pretty similar, but let's discuss how the algorithm would look like now. Which is going to be, you know, it's going to be the same thing, but, you know, personally I wouldn't come up with it on the spot. If someone, you know, tells me how it works and how we have to implement it, are, you know, 2 different things. So let's say here that we have some element, let's say a 7. I like a 7. And then we have some other ones, so let's say 1, let's say 8, let's say, I don't know, 5, 9, 3, and 2. Okay, we will take the pivot, which is, you know, kind of important, how you pick it and so on. On how you pick your element, it will tell you how long is it gonna take, you know, how many splits do you have to make. But let's assume that we're not gonna be bothered with this, and we'll just pick the first element. So it's always the first element, and if we wanna pick some other elements, something like calculate the average of all of these numbers and then pick the one which is closest or something, you can do that, and then you can, you know, swap the element with the first one, and then the algorithm will work the same way. Alright, so how does it work? We will have 2 pointers. One of them will be called left and the other one will be called right. Okay, so this is the left one, this is the right one. The left one moves this way, the right one moves this way, and they are called left and right because what we want to do is compare each element with the one that we have as our pivot point. Okay, so the left one, as you probably guess, the left one should point at numbers which are lower than our pivot point because they would have to be on the left, and the right one should point at numbers which are bigger than our pivot. Okay, and as soon as we reach something which is extraordinary or something, we have to swap the elements. So in this case we say, okay, so 1 is less than 7, we are fine, and we move on to the 8. Okay, now 8 is bigger than 7, alright, so we stop. Okay, so this is going to be an element that we'll have to do something with. The same thing goes for the right. Okay, so the right we have an element 2 which is less than 7, so we have to do something with this element as well. Okay, once we found two elements which are not what they're supposed to be, we have to swap them. In this case, this is the 8 and the 2. They're not what we would expect them to be. Okay, so we swap the 8 and the 2, and we will get another array, which I am gonna draw to be concise. So this is gonna be a 7, the next one will be 1, then we have a 2, then we have a 5, 9, 3, and then 8. Okay, our left index is here, right? And our right index is still here. Okay, now everything is fine and we keep moving. Okay, so the next one, the left one will be at 5. Okay, 5 is less than 7, so we are fine. So we move one more, we get to the 9. Okay, and now we have a problem because 9 is bigger than 7, so we stop there. Okay, for the right element, 8 is fine, it's bigger than 7. We move left, and we take the 3 here, so R will be here. This is a problem since everything on the right index should be bigger than 7. It's not, so we need to swap these two elements, and we will get 7, 1, 2, 5, 3, then 9, then 8. Okay, at this point the left and the right index are here, and once the left index has this is the same as the right one, this means that we've already sorted our sorted is not correct. We've ordered our array in the manner that we want to, and then the last thing that we need to do is just swap the 7 and the 3, and we'll get finally 3, 1, 2, 5, 7, 9, 8. Okay, 7 was our pivot point. Everything that's less than 7 is on the left, everything that's bigger than 7 is on the right. Okay, is that clear? Then we do the same thing for this subarray and this one as well. What do you mean with 3? Because we need to put 7 in its correct place, so that everything on the left of it is less than 7 and everything on the right of the 7 is bigger than 7. Okay, and to do that, the easiest way is, instead of going and looking for the specific place where to put the 7, we can just swap it with the 3. Okay, because it's first, right? So this is the first element, and I have to swap it with the last element, which is smaller than 7. Okay, and I do have the index of it. It was the last left index before we stopped this loop. Okay, is it clear what we have to do? All right, this one is easier, I think, to understand, but it's kind of a nightmare to write. So let's see if we can do it. All right, so let's start with private static void QSort, which is gonna take an array. Right, and in here we would like to say, well, if array.length less than or equal to 1, and we just want to say return. If it's bigger than 1, the length, then we want to sort. I just want to say sort, thank you, and then we have to give the array the starting index and the final index, which in this case is going to be array.length -1. Okay, why is that? Because we are only going to be working with one array, so we have to know whether we are working for the whole array or we've broken it down into smaller subarrays, and we have to work only from this index up to this index here. So we have to give a starting and an end, a start and an end index to do that. Okay, so let's implement this sort thing. So private static void sort int array. I could have just done that. That would be that would have been a lot easier. Control dot generate method, and we are good to go. Okay, so this is going to be our recursive method, where the condition when we have to exit is when the end and the start are the same. So if you give 2 points which are the same, so let's say that we call it, this has to be start and end, but anyways, so let's say that we've broken it down, you know, into many subarrays and so on. At some point you will get to a an array of a single element which will already be sorted, right? So this is what we want to check. If the index, if the start index and the end index are the same, then we have to exit the recursion. So this is going to be start, this is going to be end, and in here we would like to say if if end minus start is less than or equal to 0, we should expect the end to always be bigger than the start. We want to say return. Otherwise we want to do in split point equals split, oh come on, split escape of array start end. Okay, so this is the method that is gonna find, this is the method that I pretty much described, where you have to have the left index, the right index, you know, going from left to right, from right to left, and swapping stuff. This will be the main method that we'll use, which is gonna give us the split point, or where exactly was the 7 in our case. So we had 7, 9, 8, and then some elements here. We have to know where this number is, so that we can split the other, so that we can split the array into smaller subarrays that we have to do the same operation on. So once we have this point, which is going to be the split point, I would have to call recursively this method. So can anyone help me? What should I be writing here? So I'll have sort. It takes control shift space, it takes the array, a starting point and an end point. So what should I be writing here? Array from start to split point, maybe -1, so that we don't take it, and then again sort array from split point to end. And that's it. Okay, up to this method that we have to implement, which is the important one, but this is the recursion. So if we've reached a point where the end and the start are the same, that means that we have to go back in our recursion. We have to find the split point and then sort the left and the right subarrays, and that's it. Okay, so let's implement this one, and we will be ready. Okay, so we are gonna need a couple of variables here. So int left equals start +1, int right equals end, and int pivot equals array of start. Okay, so these are just the variables that we'll use. Okay, so we need the pivot point, which was the first element of our subarray. So I have array of start. The left starts from one index more, so start +1, and then the end is just the right is just the end index. Okay, so now let's see what is it that we have to do. Okay, so while left is less than or equal to right, okay, this will be the main condition that we will have when we move the left cursor or the left index. So as soon as it gets equal to the right index, that means that there is nothing to swap, and we should, you know, we should use something else. We should swap the first value and the left value. Okay, and one more thing. and array of left is less than pivot. Okay, so we only move left. Let me put the picture up again. So we had a 7 here, and we have the left cursor. So we move left only if we have not reached the right, and also we move left when the numbers here are smaller than the 7. So you know, this is 2, this is smaller than 7, so it's already in its right place. We move to the 3, it's smaller, so it's already at its right place, and we move on until we reach a number which is bigger than the 7 here, or until we reach the right cursor. So in this case we'll reach the 9, and then we'll stop, and then we'll want to do something with it. Alright, so here the only thing that we have to do is left plus plus, and I have to do something similar for the right. Is that clear? If something is not clear, please stop me and I'll explain more. Everything clear? Okay. Okay, so while, and we have to do the same thing, while right is bigger than left, and array of right is bigger than pivot. We want to say right minus minus. Okay, and at this point we already have the indices of the numbers that we should swap. Okay, but first we have to check if left is bigger than or equal to right. We want to say break. Okay, and this break will be breaking out of a loop that I haven't written yet. But this is just going to be the loop that's going to repeat, you know, this single operation that we do. So if we've reached, after we found the left and the right index, if after that the left is bigger than or equal to the right, this means that we have to, you know, exit the bigger loop that I haven't written yet. Okay, so here we have to swap the items, which is going to be pretty simple. So int temp equals array of left. So we want to swap the left and the right. This is going to be array of left equals array of right. Oops. Array of left equals array of right. And then we want to say array of right equals temp. Okay. And then we want to say start plus plus and end minus minus. Why do we do that? So swapping the items. Okay, so yeah, we swap the items, and then after that we just want to move one step more, but I'm not sure whether this is left or right here. Why is it start and end? Start and I think this should be left plus plus, and this should be right minus minus. So once we've swapped the elements, there is no reason to keep staying at the same spot. So let's say that we have the 7, 1, 2, 9, and then we have a 3 here. So we swap these two, we'll get a 3 and a 9, and we just have to say, well, left goes one more to the right, and the right one goes one more to the left. So that we don't end up doing the same checks. Okay, that's that. And now the only thing that we have to do is put this in some sort of a while loop, and since we already have a breaking condition, I can just put all of that into a while true loop. So Control Alt, was it S? Control KS. No, Control KS. Yeah. While, and this is going to be just while true. Okay, so we want to repeat that until the left is bigger than or equal to the right. Okay. You can reorder it in some way so that you put this condition in here, I think, but I don't know, that works fine as well. Okay, so what is it that we have to do at the end? So let's say that we've swapped all of the elements, you know, and here is the 7, here is 1, 2, 3, and let's say that this is 9, 8. What is the final thing that we have to do? Swap the pivot with the last left index that we had. Okay, so this is going to be pretty simple as well. So array of start equals array of left minus 1, and then we have array of left minus 1 equals pivot and return left. Okay, this is going to be the split point that we wanted to use. So once we do the swapping, I don't know, this was 7, this was 8, this was 9, 1, 2, 3. This is our index left, and this is the split point that we have to return at the end of this whole loop. And now this should be working. So let's create an array. Just a second. 7, 5, 1, 2, 9, 3, 2, 3, I don't know, 8, 10, whatever. Sorry, there was a question. Okay, so left starts from 0. Actually, left starts from the 0 plus 1. Right, so we had the start here, so we had left, which is start plus 1. We had the right, which is the end, and the pivot is the 0th element in this case. Okay, so let's do that. Array, actually we have to do sort, how did I call that? QuickSort. And we have to give the array, and then we have to print it. So right line string.join separator and the array, and it's gonna run the previous project, so I'll just wait for it to start here. Okay, let's stop that, and here I have to say set a startup project, and we are good to go. Okay, that was it. Let's go through it quickly one more time. So we are calling a function QSort because, you know, no one should care inside this method where we give a start and an end. You would normally expect to sort the whole thing. So this takes just the array. If it's less than or equal to 0, there is nothing to do, but if it's not, we want to sort it starting from the 0th, which is going to be our left initially, and then up to array.length minus 1 up to the last element. Okay, then we have the sort, which takes the array, start and an end. If the end and the start are the same number, then we have to exit the recursion, and inside here we just have to find our split point and call the method again. So this split method is sort of, you know, it's splitting and sorting at the same time. So this split method is the more important one. So we need the left, we need the right, we need the pivot. We move the left as much as we can until we reach a number that is bigger than the pivot. We do the same with the right, but we move from right to left until we reach a number which is less than the pivot. We have a break here, and then we just swap some elements, and that's pretty much the whole thing. So let me save it. That's all. The next workshop will be on merge sort, which is going to be slightly easier, I think.